Hello, today we are going to start lesson 4.3, which is talking about function operations, and then also something called composition of functions. So the first part, function operations, is just what it sounds. We're going to talk about using the different operations, add, subtract, multiply, divide, with functions. So today this part you pretty much already know how to do. It's just focusing on a new notation that you need to know, so that way when you come across it on the ACT, things like that, you understand what they are asking. So really it's just learning this new way of writing it. So let's look at adding and subtracting first. Obviously you guys know how to add and subtract already, but what again we're focusing on is the notation. So they're going to be giving you two different functions. So like on this one we have f of x equals 2x squared plus 8. And then they give you g of x, which equals x minus 3. And then here's the new notation, is they're saying what are f plus g and f minus g. So you're going to be seeing this kind of notation and you need to know what to do with it. So essentially they're saying take the f function and add to it the g function, and take f and subtract g on the second one. So let's do f plus g first. So f plus g is saying to take f of x plus g of x. So you'll see it written that way as well with the little x's on it. So if I do that, f of x is the 2x squared plus 8. And then I'm adding to it g of x, which is x subtract 3. And then once you get to here, it's pretty much just combining your like terms. So let's combine what we can. We have a 2x squared, 8, an x, and a minus 3. So the only thing we can combine are the two number parts. So 8 subtract 3 is 5, and we end up getting 2x squared plus x, and then plus 5 if we go in descending format. And that's your answer. So like I said before, it's really nothing new today. The only new part is just learning what this notation means. So let's do the f subtract g. As always, whenever you're doing subtractions, you just need to make sure to be careful with your signs. So if I have f subtract g, I'm going to take f of x, which is the 2x squared plus 8. And you can think of it as a group, but this whole group is subtracting g of x, which I'm also going to put in parentheses. I like to do parentheses around ones, especially when there's a subtraction sign. That way I don't forget this subtraction is subtracting everything inside of here. A common mistake that I will see is people will just subtract the x, but I also need to think of distributing that negative through and subtracting that negative 3 as well. So we end up getting the 2x squared plus 8 still, and then we have a minus x, and then when I subtract that negative 3, it turns to a plus 3, so our signs switch there. But just like on the problem before, we're just going to combine our like terms, which all we can do are the 8 and the 3 we can combine, but this time we're adding 3. So we end up with 2x squared minus x. See, I almost got my sign wrong right there. So subtract x, and then 8 plus 3 is 11. So we end up with 2x squared minus x plus 11. And that would be your answer. So again, combining like terms, things like that, you guys know how to do already. It's just learning this new notation. Okay, let's try some multiplying and dividing. So we have two new functions here. F is going to be 3x squared minus 11x minus 4, and g is 3x plus 1. And they're asking you to do f times g. So you'll see that little dot there for multiplication. And then f divided by g. And sometimes you will see it written out as f divide g this way as well. So you can do either one. But let's do f times g first, which again, you already know how to multiply. So we're just going to take the f function, which is 3x squared minus 11x minus 4, and then we're going to times it by g, which is 3x plus 1. So you have your f function being times by your g function. So essentially we're just going to be foiling it. So 3x squared times 3x is 9x cubed. 3x squared times 1 is 3x squared. Now let's do the negative 11x times 3x is a negative 33x squared. And negative 11x times 1 is a negative 11x. Negative 4 times 3x is negative 12x. And then negative 4 times 1 is negative 4. So we have all those there. Again, just combine your like terms. So we have our x squares we can combine and our x's we can combine. So we end up getting 9x cubed, and then 3x squared minus 33x squared is a negative 30x squared. And then negative 11 subtract negative 12x will be a negative 23x. And then we have that minus 4 in the back. And that would be your answer. And then we'll do the f divided by g. So for f divided by g, you just need to make sure you get the order right. So f is in the numerator. Sometimes they'll do g over f so they can switch it on you. Since f is in the top, we're going to put 3x squared minus 11x minus 4 in the top. And then we have our 3x plus 1 in the bottom. And so for this one, we do have a rational here. So you can divide it either by trying to factor it and see if that factor cancels out. You can do long division or the synthetic division that we talked about. Actually, synthetic won't work because we have that 3 on there. But let's factor this front part and see what happens. So when you have a trinomial with a number in the front like this 3, we're going to do our factor by grouping by first taking that first coefficient and timesing the last number. So 3 times negative 4 is negative 12. And we'll think what multiplies to be negative 12 but adds to be negative 11. And that will be negative 12 and positive 1. So maybe I'll come and do the whole thing on the side right here to save some space. So we end up with the 3x squared, but I'm going to split that negative 11x up to be a negative 12x and a 1x. And then we have our minus 4. So this will be a good review on factoring. I haven't done that for a while. And so once you have your 4 terms, we'll do our 2 groups of 2. And then in each group, take out your greatest common factor. So for 3x squared and negative 12x, the common factor is we could take a 3 out of both and an x out of both, so 3x. 3x squared divided by 3x is x, and negative 12x divided by 3x is negative 4. And then for x minus 4, there's nothing in common. When that happens, your greatest common factor is a 1. We still need this 1 to be here, so we can't just leave it blank. But we get the x minus 4 that we need. And so remember, when you do factor by grouping, these 2 groups need to match, which they do. We have an x minus 4 on both group. So that means we did it right. So our answer is taking one of the x minus 4s and then taking the 3x and the 1 in the other group. And that's why we need this 1 here, is because I need that placeholder, that 1, to be in the second group. So here is what we're going to replace that numerator with. We have x minus 4 times 3x plus 1 when we factor it. But lucky for us, we have that 3x plus 1 in the denominator as well. So this group cancels with that group, and we're left with just x minus 4 as my answer. So this is really just going back to that rationals unit that we did in unit 2. So whenever you get that fraction, try and factor that top and see if things hopefully cancel. And most of the time they will, because we make them to be that way for you. So that is function operations. Again, just adding, subtracting, multiplying, and dividing. Nothing new there. Really, the only new thing is just knowing what this notation means. So, okay. So now getting on to kind of the new part of today, though, and that is called composition of functions. So composition of functions is when you have 2 functions, let's say g and f again, and you're going to be, instead of just plugging a number into a function, you're going to be plugging a function into a function. So when I, for example, have told you in the past to do like, what is f of 2? That would tell you to take 2 and plug it into f, or in for x. So instead of just plugging a number in this time, though, we're going to take an entire equation. So the notation you need to know for this is, you see this little kind of open circle right here? This open circle is what we call composing or composition. And the way you would read it is you would say G composed with F, or you could flip it and do F composed with G and do the other direction. Sometimes you'll also see it written this way, where you have G and then it's like f of x is being plugged inside of the G function. So they're kind of like sandwiched in. So here's our f function being plugged into the G function inside those parentheses. So G composed with f means to do G with f plugged inside of it. So the order here is whichever one goes second, is in the second spot, is plugging into the first equation. So that order is important and it does make a difference. And what we're going to end up doing is we're going to kind of work from our inside out. So we're going to look at f first. We're going to evaluate f of x first and then use that to plug into the G function. So kind of working our way backwards. And it's important to note that the order does matter, and F composed with G doesn't always turn out to be G composed with F. Most of the time it actually doesn't work that way. So we can't just plug one into the other and expect the same answer each time. So be careful on the order of how you plug them in because it does matter. But let's look at some so you guys even know what I mean by that. These first ones, we're going to make it a little bit easier. They're actually easier when they have a number to plug in like this. So again, think of this notation f of x means a function of x, where x is your variable. If I tell you to do f of 2, that means to plug in 2 into your x, right? So they're saying to take 2 and plug it in for x. What we're saying here is we have f composed of g of -3. If it was just g of -3, it would be saying to plug -3 into g. But we also have this part. So when there's the number, I think it's actually a little bit easier because what you're going to do is you're going to take -3 and you're going to plug it into the G function. So here's our two function equations right here. They've told us f is x minus 5 and g is x squared. So what I'm going to do first is do g of -3. Again, we're kind of working our way from the back. I'm going to take -3 and plug it into x squared. So that means instead of x, I'm going to do -3 squared. Well, -3 times -3 is +9. This new number, we're now going to take from g and plug it into f. So we're going to take 9 and plug it into f and do f of 9. So if my equation for f is x minus 5, instead of x, I'm going to do 9 minus 5, which is 4. So again, we're kind of working from back to front. -3 is going to plug into g. Whatever you get out of that is then going to plug into the first function, which was f in this case. Okay, let's try another one. So here's our equations this time. G of x equals 2x, h of x equals x squared plus 4, and they told us to find h composed with g of -5. So again, that's how you would read that. H composed with g of -5. So we're going to start from back to front. We're going to plug -5 into g first. So g of -5. Well, my g equation was 2x. So instead of x, I'm going to write 2 times -5, which is -10. That answer is what we're now going to take from g and plug it into h. So I'm going to take this output that we got and plug it into h. So we're saying, what is h of -10? Well, our equation was x squared plus 4. So instead of x, I'm going to do -10 squared plus 4. Well, -10 times -10 is 100. 100 plus 4 is 104. And that would be your answer. And I just want to show you guys how the order does matter. Let's flip it. Let's do g composed with h of -5. So we're still doing the same number and the same equations, but we flipped the order. So I'm going to do -5 plugged into h first. So I'm going to do h of -5, which if my h equation is x squared plus 4, I get -5 squared plus 4. Well, -5 squared is 25. 25 plus 4 is 29. Then I'm going to take 29 and plug it into g. So G of 29, if I do that, G was 2x, so I'm going to get 2 times 29, which is 58. 104 does not equal 58, right? So that's, again, why that order matters. We can't say that H composed with G does not equal G composed with H. So that's a really important thing to remember. The order is very important. Okay, so far everything we've done has been with numbers first that we've been plugging in. But sometimes I might have you do a letter. So on this one we have F is x squared, G is x minus 3, and they're saying do F compose with G of A. So we're plugging A in instead of a number. We're still going to do the same thing where I'm going to plug A into G first. So G of A, well, I'm just going to be replacing x with A. So I end up getting A minus 3. I can't really do anything because I have a variable and a number and they don't combine. So we still have to finish the composition though, and whatever we got out has to plug in to F. This whole thing is now going to plug into F. So I'm going to plug in A minus 3 into my F function. So in that equation, wherever the x is, I'm plugging A minus 3 in. So instead of x squared, I'm replacing x with A minus 3. So I have A minus 3 squared. So that is going to happen a lot too, where you might not necessarily be plugging a number in and you won't get a number answer out, but you might just be plugging an entire equation in and getting an equation back as your answer. And that is okay when that happens. So let's look at one story problem really quick though. So on this story problem, it says a store is offering a 15% discount on all items. Also, employees get a 20% employee discount. So write a composition function. So in a way, what's cheaper? Is it better to do the 15% discount than the 20%, or should we do the 20% and then the 15%? So we're going to model taking the 15% discount and then the 20%. When it says to model, that means to write an equation or a formula. So remember, the order matters. When they say write a model doing the 15% first, then the 20%, we need to think we have some composition, right? Where we have a little space composed with something here. Think about which one should go first. When we were up here, the second function was really the first one. We plugged it into the second function and then that plugs into the first function. So if I want the 15% discount to go first, it really needs to go in this place. And then the 20% discount needs to go here. We also should probably come up with variables. Let's say that the 15% discount, what should we call that? Let's just call that C. And then 20% discount, let's say that is D. So if I want the 15% one to come first, we're going to use C as the name for it. We're going to put that here, and D will go here. And then let's do the reverse. Now it says model doing the 20% discount and then the 15%. So again, if we have our little composition set up, we have our two spots here. If I want the 20% discount, which again we're saying is the variable D, and 15% is the variable C, whichever one I want first really goes second. So I want to put the D here and the C here. And then, what do you guys think? If you were the employee, which discount would you want to take first? And then why? Would we want to do the bigger one and then the smaller one, or the smaller one then the bigger one? So think about that for a second. Should we do 20% and then 15, or 15 and then 20? So I think you probably want to do the bigger one first, because you're going to take the bigger discount on the original price first, so you'll save more money that way, and then do the smaller discount on the smaller amount, rather than if we did this direction. If we did the smaller amount first, you wouldn't save as much money on that initial chunk, and then you would be taking a bigger discount second, but it would be on less money, so it wouldn't be as good. So you would want to do the biggest discount first. I wrote that in the wrong spot. Since it will save you the most money. So I think we won't worry about this other story problem for sake of time on the YouTube video. But let me know if you guys have any questions. We're going to be working more with composition this unit, so this won't be the last day we see it. So if you're still a little bit wary, don't really understand it, that's okay, because we're going to get more practice with it next time and the time after that. So let me know if you guys have any questions or need help with your homework, though. I am here to help you, and I'm happy to help you. Send me an email and we can set up a Zoom time to talk. Hope you guys are doing well. See you later.